Hi, I'm John McDermott. Welcome to IoT Auckland. This is the first meetup recording that we've done. So this is a recording of the online meetup that took place on the 31st of March 2020. And our features today are a demonstration of a USB oscilloscope that I sourced recently and a demonstration from Derek Beckett of Ping Alert of their sensor platform. Hope you enjoy. Thank you.
Okay, so it looks like we've got a good number of people joined in. So thank you very much, everyone. Some news. Let's get into some news. So some news items. So this is just some interesting things I saw during the week. So we've mentioned about 5G previously, and I saw some news that BMW are going to get a 5G license that they want to use inside their factories. So this is kind of interesting that they're not using a traditional cellular operator, but they're going to buy and install the equipment themselves to use inside a factory. And I think this is actually an example of where I think 5G might actually be very successful. It's not as a broadband network for public use, but actually inside factories for industrial use. So this comes into the industry for industrial IoT applications, where instead of wiring up equipment with Ethernet cables or fiber optic cables, they can put in a 5G network to give them high speed, low latency broadband. And that makes it faster to equip factories and easier to adapt and alter factories. So quite interesting to see BMW doing that. And I've got the link through to that piece of news. I will make a PDF out of the presentation and share this around to the group as well. Next thing, kind of the other end of the spectrum from what's going on is I've been keeping an eye on satellite operators, all the new satellites which are going up, and unfortunately one of them has already gone bankrupt. Partly they're sort of blaming the coronavirus downturn for this, but OneWeb is actually a UK-based satellite company. Although they seem to have operations in the US and the company is licensed in the US. So they were planning to put up 650 satellites, and they got as far as 74 in orbit, but they were needing to get some extra finance to keep going, and it looks like that financing has fallen through. Now this is kind of a deja vu. I mentioned Iridium there. So Iridium is one of the existing satellite operators who provide phone calls and low data rate data connectivity around the world. But Iridium had this exact same problem maybe 25 years ago. They launched 60 odd satellites, but then ran out of money and went bust. But because the satellite's already in orbit, you can't take them out. So they're actually up there. So what happened was Iridium was refinanced at a lower valuation and then went into operation. So just because OneWeb has gone bankrupt doesn't mean to say that the system fails. So we'll keep an eye on what happens there. They may get new financing to carry on. They may get taken over by someone else, but you know, the satellites are up there. They probably work, I assume. So something may happen to them. So that's quite interesting. And as a comparison, OneWeb are setting up to compete with Elon Musk's Starlink, and Starlink is getting a lot more attention because of their SpaceX launches and the fact it's Elon Musk, and they've got a lot more capital behind them. And then interestingly enough, Amazon or with Jeff Bezos are also going to do their own system called Kuiper. So if you've not already paid attention to this, it's certainly quite an active area of launching satellites into low Earth orbit for data connectivity. These ones here are at the top end of the capability in providing broadband, but there are others who are doing small packets, low data rates for more IoT type applications. So that was quite interesting. what have we got next? I found some podcasts which are interesting to have a look at potentially. So EVNEX, based down in Christchurch, I think. So Ed Harvey presented at our IoT conference a couple of years ago, and he was very interesting to see how he's doing. EV Maritime are based in Auckland, in East Tamaki, and Michael Eglin has done a podcast recently, and that's actually quite interesting to listen to. Yeah, so a couple of podcasts to listen to if you've got the time. Michael's is really interesting. He's setting up, his background is in boat building, yacht building, and they're starting up a business to construct electric ferries, and they're working with Auckland Transport and Mackay and a couple of others to specify those. And what was interesting about that is it's not just about building the boat, it's all of the systems and processes and infrastructure that enable that to work. So you need charge stations on the ferry terminals. So you need to have that infrastructure in place. So you now need Vector and your electric utility to step in to provide that. You need to have a much better scheduling of ferry arrival times so that they have access to the charger. Because if you've got 5 ferries that all turn up with only one charger, then that wastes time. So you need to much better scheduling operations. So quite an interesting one to listen to. Something else I spotted during the week, but seems to have hit the pause button, is Spark have got a little competition going out. So if you've got some really bright ideas for using 5G, then Spark are on the lookout to hear about that, with a competition to provide some funding to get you going. So $250,000 first prize and a couple of $125,000 prizes, and potentially the chance of a trip to New York once the planes start flying again. So that's actually quite good to see. So we'll keep an eye on that, and if they come back, we'll put that announcement out and find out what's going on there. I did try to reach out to Spark to find out more, but didn't get a response. So if anyone's got better contacts than me at Spark, then we'd like to hear more about that when it gets back into action again. So let me do my demo time. I've got my little oscilloscope here. So what I'll do is I'll just show you quickly, bring my camera up to show you what the unit looks like. It's like that little picture there. And then I'll get a couple of signals to show you it in operation. The specifications up there. So this unit cost me about $150. So actually very cheap, I think, for its capability. Not super high spec, you know, it's only got a 35 megahertz bandwidth, 100 megasamples per second. But for a lot of hobby type use cases, Arduino, our PyCom units, if you're using those, it's quite a handy little unit. So let me show you what that looks like. So I'll just move my camera. So that's the little box there. So about the size of my hand, and it plugs in via a USB cable into the back of my computer. And then we have two scope probe inputs, and then there's a little cable here, which I'll talk about in a moment. So let's put that back. So what I have here at the moment is I'm just making a 1 kilohertz tone, so you can kind of see what something looks like. But what I'll do is I'll just flick this over, and so that's a signal trace coming from my phone with some music playing. So it gives you a bit of an idea of what it can do. So what we've got on the screen is we've got some time controls. We can move around to speed things up if we want a fast signal, slow it down. And there's our voltage. base as well, so we can reduce the gain on the signal that we're watching. And we've got two channels. I've got channel B turned off at the moment, and here's our trigger setup. So I can either turn the trigger off and it just goes, or we can set the trigger and move the trigger threshold here. So that's quite nice. So there's a little box up in the corner here, so it's able to actually kind of take continuous screenshots to produce a movie as well. So we can actually capture all of that data and use it to just run there in the background for hours on end if you really wanted to do it that way. If I stop this, just show you, so this little red box here is actually the whole of the memory buffer. So this is the entire signal is captured, and then it gives us like a high resolution view in the middle of where the trigger point is of what's being seen. So that's quite nice. Let's get that going again. So the decode is this bit down here. So you can see there's a message being sent. If I just do that again. So if I send 1, 2, 3, 4, 5, 6, you see the decode here at the bottom says 31, 32, 33, 34. So that's the hex character for the ASCII 1, 2, 3, 4, 5, 6. So that's, as I said, it's a really handy little method of making sure your serial lines are working. You know, there's always issues of, is my data actually the data that I want? So that's actually quite useful little function. So let's come back to my other thing. So actually a very useful little feature if you're looking at sensors in an IoT system, or you've got a serial communication line between sensors to actually check that the data is working as you expect it to. So that was about $150 for this little box. So I was quite pleased about that. And I've been in contact with the manufacturer, so it's a Chinese company. And if anyone else wants some of those, let me know, because we might be able to get a better price than their standard kind of AliExpress or the online sales shop pricing. What else did I have? Oh, yeah, there's a logic analyzer. So for those of you who are used to using scopes and logic analyzers previously, there's a little 4-line logic input for decoding logic as well. So that's quite handy to have for sometimes. So yeah, when we get to open up the floor, if you've got any questions about that, let me know. So 2 weeks ago, I ran the IoT Biz webinar through the IoT Alliance, and that went reasonably well. Now I've got all of that recorded as a video. So if anyone is interested in that that course, then get in touch and we'll see how we can make that available. As I said, it's a 3-hour-long video, so I can put that on YouTube, and then you can watch it in bits and pieces as you like, and we can provide all the course material. It's a PDF and there's a booklet, and Certain Access provide an online exam that you can take for a credential. There is a cost for that, but as I said, if there's interest in that, I can make that available for people. So that's quite good fun to do that. So Derek, give me a thumbs up. You ready?
Let's have a look. I'll just put that up. Well, I haven't really got a presentation or anything organized, so. But what I can do is, I'm sharing you at the moment, but if I just fire that over to there. So can everybody hear and see me? Oh, you can see me, John? Yeah, okay. Oh, okay. All right, guys, well, I won't be too long. I'm just, I've been working with John a little bit in the past. He's sort of partly a customer and partly a supplier, colleague, obviously. I've come from a company called Instrumatics, where we supply instrumentation to the process industry. We supply flow meters, level sensors, lots of devices for places like BMW, manufacturing plants, where online we can supply a field instrument and make some local display. But of course, in the past, everything's been powered. But now in the environmental industry, we've had a number of customers asking us to measure levels under manholes, measure levels of bridges in the middle of nowhere, water quality out in lakes and rivers, etc. So about a year and a half ago, I got involved with another work colleague, and him and I have developed another company called Ping Alert, which is an IoT-based device, and I'm sure you guys are pretty familiar with most of the devices. You can have anything from GPS trackers to obviously the LoRaWAN for flow meters and for lots of other environmental areas. But what we just decided to focus on was to take specialized, pretty expensive instruments and connect them to a cloud. So what we developed is, I don't know if you can you see this? May not show too well here, John, but okay, so this is the device that we've developed here. We've got a sensor input here. I'm going to try and open that without damaging it. Can that still be seen? Yep, sort of. Yeah. So we have a lithium battery pack here, a PCB that we've developed, a DC to DC converter, and a power supply here. On the back of this, our main PCB, we have a SIM card, which at the moment we're using Cat M1, but we've developed that for NB-IoT as well. Not for LoRaWAN. We're going to just focus on the device by device signaling, not multiple devices or sensors, if you like, coming back to one device, one gateway. So ours is going to be one device, one signal, pretty much. Anyway, so our unit here, we can program that to wake up daily, hourly, half hourly, etc. The unit wakes up, sends a signal to our sensor. Now, the sensors that we're using, here's an example of one here. This is a radar. So this is a $2,000 instrument, which is a level instrument which can measure up to 30 meters. It's an analog instrument, so it uses 12 to 16 volts analog signal, so 4 to 20 milliamp, which was probably our biggest challenge of developing this box, was to make the 4 to 20 milliamp signal actually work with the 5 volt digital SIM system. So, but anyway, we managed to do that at relatively low power. So the unit wakes up, but with analog instruments, they take a little bit of time to start up and to settle themselves before they show a good signal. So we turn this instrument on for 1 minute, just to we send our voltage out to our sensor. It wakes the sensor up. It then stabilizes. The 16 volt signal comes back into here, gets converted by the DC converter back into a digital signal, and then that digital signal is sent off to the cloud using a SIM via the SIM. Power supply there. So with at the moment we've got, for instance, this instrument set up to measure once an hour. So the unit will wake up once an hour, talk, and then go back to sleep. Other clients, for instance, I'm thinking of one where we've put one in a toilet. They only need to measure once a week. So we wake it up every Thursday. We see what the level of the toilet it's a held toilet in the middle of nowhere with no sewage. So we're looking at what level the water is in there. It wakes up only once a week. So of course we can put in a single battery which will last for many years. Whereas when we're using a high voltage, we're needing to wake our instrument up quite regularly, and it's a real power sucker. It really drains our 3.7 volt lithium. So what we're also doing is we've got another input here where we feed in a solar panel. The solar then comes into the power supply. Power supply charges our lithium battery, and the battery becomes a holding bank, if you like, which can last somewhere between 4 and 6 days until another charge comes in at 1 hour signal. If I put that down for a sec and then put what we've done is we've created, what I've got to do is I'm just going to present now, put a window on, which is that, share, just share John again for a second. And then, John, can you see that the page of our ping alert site?
Yes. Yeah,
Okay,
that's right.
so what we needed to do was develop that a back-end website which takes the data. So our data goes up to the cloud. We're using M2, M1, who are hosting our SIMs. Our SIM data gets transferred across to this back-end website here. And what you can see is we have home, we have a number of clients. Each client has a number of users, and each user or each client has a number of devices. So they may have 6 devices, for instance, all looking at levels or water quality, what have you. They click on which device they want to see. And you can see here we've got an API key in. You probably can't see it, but there's an API in and an API out. So our clients can bring the data straight to their own systems. We can set alerts across here. So when our battery level is getting low, for instance, or when our river level is getting, let's say, low in summer or high for flooding situations in winter, we can set those alerts. And then we can have a number of charts for different devices. So in this case, we have one, which is our bar graph here, which shows our power, and we've had that running for quite a while. We're looking at still sitting on 4.01 volts, and that was as of 13:03 today. Over here is our river level. This is a simulation we did, but ignoring that, we can point our radar, which I just showed you, at a number of items, or in other words, hang it from a bridge, and we can see the history as to what our device has done. One other input we can have is a switch. So we could, if we wanted to have for instance, in a flooding event, we could have a float switch out in the environment. When a flood happens, what that'll do is switch the unit on and force a signal. In other words, have an alert to the cloud and to all the users to say, hey, you better go and do something because you've got a flood on its way. So that's a very brief. In addition to the back-end website, of course, we have our main website, which is our marketing one, which shows our products and our sensors and all our availabilities. I'm just going to stop presenting just to bring that back. So can everyone just see me now, John?
Yes.
Oh, okay, good. So just very quickly, in addition to the radar that we have, we can use that. We can go out and look at soil moisture content for the irrigation industry, farming. We can look at pH levels for out in river flows and lakes. We can look at gas detection, either CO2 monitoring for the environment or as a danger, for instance, in treatment plants or out on sites where in the middle of nowhere where they're using dangerous gases and something nasty might happen. Basically, if it's an analog device, we can put it into our little ping alert unit and talk to the cloud. Easier still, again, if we can get it, there are some sensors available which are 0 to 5 volt digital. We can bring those digital signals straight into our device, and we don't need the DC to DC converter. It's a hell of a lot easier and obviously cheaper for us. So that's pretty much a quick summary of the product. I just saw in the comments, John, that someone inquired about a GPS tracker for they wanted to look at pallets probably moving around the world or moving around the district. That's something we're working on. That's normally a lower cost item, so it's a tricky one with pellets. There are actually a couple of people out there in the market that are using that. Most of them use LoRaWAN, and if you want, I could tell you who they are. I can't remember off the top of my head, but I can find it out. There are products. One of our developers, Vega, this product here, is developing something that does that. The only key that they have that we don't is the GPS tracker. As I'm sure you'll know, you can get a GPS unit and attach it onto your PCB and make it work, which we've done in the past, but we found that was starting to use quite a lot of power, so we dropped that back because power was a major for us. But yeah, so we're wanting to move into any ideas or any problems that you guys have got and where you've got no power, you've got no connection, let me know because we're very interested. We're really only just launching. We've only just launched and sold a couple this year, so but been working on it for 18 months. So exciting project, but always looking forward, you know. So
no,
yeah.
good. Thanks, Derek. Let me ask a couple of questions, and then if anyone else has a question, then please shout out as well. So I'm curious. on your sensors, and then about the Cat-M1 module, is how challenging was it to do that integration, for your sensors into your unit, and then that decision about using Cat-M1 instead of a regular LTE connection, as to any particular sort of challenges or experiences from doing that?
Well, we were kind of lucky because sort of mid to late last year, Spark and Vodafone both came out with their Cat-M1s and came out with their dev kits, and were quite helpful with us. We half helped them with some of their education because they hadn't had many users. So we're quite lucky to have a little bit of free support there from there. When the first instrument we used was a product called Maxbotics, a fantastic level instrument, which is an ultrasonic you use, and it is made in the US, and it has a 0 to 5 volt digital signal. We took one of those, we put it into our board, we made the sim work in the background, and it worked almost straight away. Not with our website, we used another website called Ask Sensors, which is a generic website somewhere from Europe, which allowed you to be able to do your back-end coding and update, link your sensor to, their back-end signal, and then we could just look at it, see our output from there. So when we started searching, there was quite a lot available. Probably the hardest thing to find was actually the modem. There's very few modems around, the manufacturers around the world that can handle Cat-M1 and NB-IoT. So we've ended up, we had obviously a few developments for when developing the PCB, and some of the earlier ones we did the breadboard thing and then put the PCB together, had a couple made up, pulled that apart, redrew our own PCB, and then ended up we couldn't get, so we had PCBs made in China, but we certainly couldn't get the modem in China. So we had to source the modem from one place, send that to our PCB manufacturer, get it put together, and then sent it all back. So actually, probably the back end was probably easier than the actual hardware side of it.
Mm-hmm. Oh, no, that's good to hear. I'll make sure we put Derek's contact details into the what we share around. Okay, right. Let me grab back from you, Derek. So thanks very much for that. And as I said, if anyone wants to contact Derek, then his Instramatics is the business, but I'll share those contact details as well. I'll just come back to my oscilloscope for a moment, because whilst Derek's been talking, I got the decode working. So the decode is this bit down here. So you can see there's a message being sent. If I just do that again. So if I send 1, 2, 3, 4, 5, 6, you see the decode here at the bottom says 31, 32, 33, 34. So that's the hex character for the ASCII 1, 2, 3, 4, 5, 6. So that's, as I said, it's a really handy little method of making sure your serial lines are working. There's always issues of, is my data actually the data that I want? So that's actually quite useful little function. So nearly finished. I found some other links which I thought might be quite handy to share around in present times. So if you want to look for helping other people, then Voluntarily has been set up for matching people up who need help with people who want to give some help. So that's a nice little addition to the community. Two others more from a business perspective is one is scale.ai, which is a platform for matching up contractors. So I think it's a little bit like I can't remember the name. One of these websites for matching contractors with people who have work to do, but obviously targeted at Kiwi businesses. So take a look at that one. And then the other interesting one, which I think is in its very early days, only running for the last week, but worth keeping an eye on, is Manaaki. So This has been set up with the help of Andy Hamilton from the Ice House, and they've got some quite high-powered, high-profile business people who are offering their expertise and their contact network for people. So if you've got, it's basically throw your question out, and that will hit a platform of experts who are giving their time for free to either offer advice or help connect people up. So that looks like it could be quite a useful system for extending your network of contacts in the business community. So it's not although it's been set up by tech people, it's not specifically tech orientated, although that is one of the subjects. But it's basically any business on any subject. So nearly finished. I was just going to again open up the floor if anyone has if anyone has a question or a comment, then stick your hand up or write a question in the chat, and we'll see what's going on. Especially if you want to introduce yourselves, because obviously in this environment, it's quite difficult to say, well, who are all these people that are here, and why are they here, and what are they doing? So it would be kind of nice if one or two people would say who they are, what they do, and if they've either got something interesting that they're doing, or they need some help or advice, or have a question, then this will be a good time to throw it out. Otherwise, you're quite welcome to go back up onto the meetup.com website and put a question at the end of the meetup page, and I'll take a look through those and try and help people out. So I'll take a pause for a moment, because I know we've got some interesting people who have dialed in today. Come on, is anyone bold enough? You can either click on the microphone yourself or just put a question in the chat button. Okay, so whilst we're doing that, in terms of using this format, it's I'm quite willing to keep doing this. So if we get another presenter or some other topics in particular to look at, we could run another event next month or the beginning of next month and see how that goes. Otherwise, I did think we could maybe do this as a weekly virtual sort of drop-in website, and just open up the chat and the presenter. So if anyone wants to come in and just have a chat with people, catch up on what anyone's doing, we could come and do that. So I'm open to suggestions on that. So other than that, I think we've probably brought things to a close. No one's bold enough to stick their hand up. Anyone got any feedback that they want to give about today? So Alberto says the format's great, so thanks very much. That encourages me. So I think I've just come back to my camera. So thanks everyone. I'll leave this open for a few minutes. So if you want to hang around and have a chat, you're welcome to do so. Otherwise, really pleased that we had 20 or so people dialed in for this afternoon. I thought doing this at 1 o'clock might help break up your day, because I know we all go a little bit stir crazy sat at home trying to find something to do. But otherwise, thanks very much for dialing in, everyone, and we'll see what we do next time.